Okay, all right. Well, it is week 8. Just a little bit of time left in the quarter. So, week 8. We have 3 lectures this week: Monday, Wednesday, Friday, and then next week I'm only going to have lecture on Monday, and I will cancel Wednesday's lecture, and you'll have Thanksgiving holiday. So week 9 is just 1 lecture, and then week 10. I guess we got a couple lectures there. Monday, Wednesday, Friday. Usually, I don't like to do too much new stuff like the last, 1 or 2 lectures of week 10. So probably we're looking at like 5 lectures of like content that I would feel comfortable putting on the final exam, and then maybe the last 2 lectures of week 10 will just kind of be fun things in Python that I think are cool that I won't necessarily test you on, okay? I am still trying to think of the proper format for the final exam. I know a couple things. It's going to be pen and paper, and pen and paper programming computation exams are always really kind of tough to write and see how it goes. I'm toying around with a few different ideas as far as like what I want to ask you guys to do. So one thing that I want to do, and I'm debating how much the exam will look like this, is I'm going to basically I'm going to like write a prompt. I'm going to put it into ChatGPT, and it will spit out some code, and then I will have you evaluate that code that ChatGPT outputs, and you tell me if ChatGPT did a good job or bad job, okay? Because I feel like that's kind of like an important skill that you're going to need, because I feel for me to pretend like no one's going to use ChatGPT in the future, I think is dumb. Okay, because I think like it's a tool and it can be useful, but also I think it's very risky to trust it blindly, and so I want to make sure you have the ability to kind of read output and then also kind of think critically, and that's actually going to be an important skill to develop, kind of professionally as well, because I don't know, you probably won't go into software engineering jobs, although some of you will go into software engineering jobs, and part of your job will be code review, where you're reading other people's code and you have to evaluate other people's code. And so, it's kind of like that. You're basically doing a code review of ChatGPT's output, where it has output something and you have to evaluate. Now I have to figure out how to score something like that, right? Like if you, I was going to say, like circle any errors that you see, and I don't know. So I like the idea. Practically putting it into an exam, I could see it going well or poorly, and so there's always a little. So anyway, we'll see how it goes. Once I figure out a little bit more what the final exam looks like, once I have a few problems that I feel good about, I'll give you some more information. But that's one thing I'm thinking about. Okay, all right. Anyway, let's take a look at more object-oriented stuff. And this lecture is on classes and inheritance. Okay, so inheritance. And I'm taking all of this stuff directly from. This is actually the 2nd edition of Think Python. But I think still very similar. The chapter number might have changed. Okay. Inheritance is the idea of defining a new class that is basically a modified version of an existing class. You kind of have this parent-child relationship where, the child inherits qualities from the parent, but is not going to be exactly the same as the parent, okay? All right, and so the idea, we're going to develop a class for dealing with poker hands, okay? Card hands, all right. Oh, okay. you guys are working on homework 4. Maybe you're done with homework 4. It's due later this week. And then I'm going to post homework 5, and that will be the last homework assignment, okay? And I'm not going to assign any more chapters from Data Camp. You do have access to Data Camp a total of like 180 days from the first day of class, basically, or maybe like I want to say it goes into like March 25, 26, something of next year. So you have access to Data Camp up to that time. If you're bored over winter break, go ahead, study as much as you want, okay? Learn as much as you want. And it's a great resource. I think there's a lot you can kind of learn. And I don't know, if you've completed a chapter, you get like a little certificate. I don't know if that means anything to anybody, but it's there, okay? I'll just say, I hope the Data Camp stuff felt like it was okay. And then, yes, one more homework assignment. So that will be homework 5. You'll see that posted in the next few days. And that will be the last homework assignment for this class, okay? But one of the assignments or one of the problems in homework 5 is challenging, okay? So don't leave it to 2 days before the deadline to get started. It's going to require some thought and thinking. So
how much time will you get from like 2 weeks?
Yeah, I'll make it due during week 10, so you'll have 2 weeks. Yeah. So okay. So standard deck of cards has 52 cards in a deck. Okay. I don't know, maybe 2 more if you can count the jokers. But as far as the regular cards go, you have 4 suits: spades, hearts, diamonds, and clubs, and 13 ranks. Okay, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king, in that order from lowest to greatest. Well, I guess the ace can go on the bottom before the 2 or after the king, but that's the idea there. Okay. We want to create an object that's going to represent a playing card. And so basically, as far as the playing cards go, there's 2 attributes. We need to keep track of a rank. We need to keep track of the suit. Okay. How you want to store these attributes is not going to be obvious. Okay. And with things like spades, hearts, diamonds, and clubs, we might want to store the suits as strings, okay? But then we are unable to do any kind of comparison. Now you might wonder, like, well, how do you even compare a heart to a club or something like that, okay? In some games, the suits are in order, and so bridge. It's like an old person game, but I don't know. Does anybody play bridge? It's like your grandfather used to. Exactly. That's a kind of we have derivatives of bridge, like hearts and spades, which show up on your computer, and like those are it's a trick taking game and stuff like that. But anyway, bridge has orders to the suits. And the order is spades are the strongest suit, clubs are the weakest suit, and things like that. And so we might take a cue from there, and this will allow us to kind of put the deck in order and things like that. And so in order to kind of have, we're going to basically convert the suit into a numeric value. So we can say spades will take on value 3, hearts 2, diamonds 1, clubs 0. And so this is kind of an idea of encoding the suits as numbers. And we just have to remember to kind of translate 0, 1, 2, 3 back into these suits. Okay. We'll also just for jack, queen, and king, we will just give them numeric values. Okay. And so we'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack will be 11. Queen will be 12 and king's 13, and I think that feels rather straightforward, okay? And so we are going to create a class of object called capital C card. Here, let me restart and clear all of my outputs. Have we come around to liking Git and getting content from Git? Maybe, I don't know. Well, I like it. All right, so class card, and right now we're just going to have one method for initializing it, the init method, and so basically we're going to give it two things, a suit and a rank, okay? And we will assign it as attributes. So self.suit is going to be the suit that comes in, self.rank is going to be the rank that comes in. The default values will be 0 and 2, so that would be the 2 of clubs is the default card, kind of the weakest. All right, so if I want to create a card, I can do card 1, 12. This will be 1 is diamonds, 12 is a queen, and so this would be the queen of diamonds encoded. All right. Now, if I ask Python, hey, what is the queen of diamonds? It's going to give me this, which is never really useful. Okay, we have. It is an exam. It just says it's an instance of the card class object located at this location in memory. And again, not readable by humans. I have no idea what's in here. I have to do something like queen of diamonds dot rank, queen of diamonds dot suit to kind of get back that information. Obviously, it would be much better if we have a method that will print this out, okay? So we will use the _string method, okay? And this will return a string representation of the card, okay? And that will get printed out anytime I call print. So basically, in my card class definition, I'm going to put in 2 additional values here, okay? And these are not, notice I don't call these self.suit names or self.rank names. These are not attributes of the card. It is just information that exists in here. And we're going to say we've got clubs, diamonds, hearts, spades. This corresponds to index 0, 1, 2, and 3. And then the rank names, I put in a none, and then ace, 2, 3, so on and so forth, because the ranks go from 1 to 13. Python is 0 indexed, so I need to kind of put in a placeholder for the 0 index, which, so I'm just going to put in a none right there, okay? So we have rank names there, and then what we'll do is we will subset the suit names. So we've got capital C card, okay? So it's not a self.suit names, it's an attribute of the class card. So card.suit names, and we'll get self.suit, we will subset to the suit, and then we'll do card.rank names and subset to that, and then we will put that into these placeholders. And so this is the string representation will be blank of blanks, okay, and that will be the string representation. So here if I do, let's define card 2, 11. The 11 is a jack, 2 is a heart, so this should be the jack of hearts, okay? And that's what we get, right? Oh, okay, and here we go. Variables like suit names and rank names are defined inside a class outside of any method. These are known as class attributes because they are associated with the object class capital C card, okay? And so when we call them, they are not self.suit names or self.rank names. They are capital C card.suit names or capital C card.rank names, okay? These are distinguished from attributes like suit and rank, which are instance attributes, and they are defined by each particular instance, and they are preceded by self, okay? All right, so what is this going to be? Card 1, 1. That will be ace is the rank, and then 1 is the suit. So the suit is clubs is 0, diamonds is 1, hearts is 2, so this will be ace of diamonds, okay? And so now, you know, because I've implemented the string _string method, I can print these things out, okay? So now I have the 6 of spades there, and so this is at least readable to us. Okay, what if I want to compare cards? What if I want to compare cards? Okay, So we can do relational operators like greater than and less than, okay? And we can implement those into our class definition, okay? And so it uses a special Dunder method, okay? And we have Dunder LT. So this is, again, similar to the operator overloading where we did, double underscore add. And we said, okay, well, this is how you can use the plus operator to add objects, okay? So we did that with the time object, and I said I want to do this time plus this time, and I want to add those together. Now I want to say here's a card, and here's a card, and I want to do a comparison. I want to use a less than or greater than to kind of compare these. So you have this double underscore LT for less than. You also have double underscore EQ to test for equality. And these things will return true or false, right? You basically do card 1 and card 2, self versus the other. And then if self is less than other, it will return true. If self is greater than other, it will return false. And so, so we have to choose how do you compare two cards. So how would, so you want to think, if you were to sort the deck from one end to the other, how do you want to sort the deck? Okay? And there's a couple ways. Is one, you can sort by rank first, and you put all of the aces together, then all of the twos together, then all of the threes together, and so on and so forth. Or if we said sort the deck, and you say, well, let's put all of the spades together, and we'll put those ace through king, and then we'll put all of the hearts together and put those ace through king, or something like that. How do we do that? Those are kinds of the ways. So what we're going to do is we're going to sort the deck first by suit and then by rank. Okay, so all of the aces will go together. All of the spades will go together, and we'll sort within the spades ace through king. Then all of the hearts will go together, and then within that we'll sort them ace through king, and so on and so forth. And so in that case, when we compare them, we're going to basically create a tuple. First, we're going to give suits the first priority, then the rank. Okay, so for the less than, we have the self. We're going to compare it to the other card, the self card versus the other card. We're going to create the tuple for the self card, and we're going to do suit, then rank. And then for the other card, we also create a tuple of suit and rank. Okay, so we got tuple 1 and tuple 2. And now that you have tuples, you can just do, and these tuples have numbers in them, 0, 1, 1, 12, or whatever. Now you can do a comparison. Okay, and so because we put the suit first in the tuple, all of the spades will outrank all of the diamonds, all of the spades will outrank all of the hearts, which will outrank all of the diamonds, which will outrank all of the clubs. So, the ace of clubs, according to this, is is ranked lower or less than the 2 of diamonds. Okay, and you might disagree on how this is, but that's how we can do that. Okay. The double underscore equality method is going to be very similar, but we're just creating a tuple out of the suit and rank, tuple out of the suit and rank for the other card, and it's going to return the result of a test for equality. Is T1 equal to T2? Okay. And even though we've only implemented the less than sign, the less than automatically will do a greater than. Okay. So the greater than will do. Basically it will put the self on the right-hand side type of thing. So, okay, so now that I have this, okay, I can create card 1, which will be the queen of diamonds, and I can create card 2, which will be the jack of hearts, okay? And so here we're basically creating a tuple out of these, the suit and the rank. So we've got suit diamonds, rank is queen, suit is heart, rank is jack. And so if I want to compare these, basically all of the diamonds are ranked lower than all of the hearts. So card 1 is card 1 less than card 2. that will be true because all of the diamonds are ranked lower than the hearts. Okay, so that will be true. Okay, here I can create a third card. This is the Queen of Hearts. Is the Queen of Hearts? How does the Queen of Hearts compare to the Jack of Hearts? Okay, so card 3 versus card 2. Queen of Hearts versus Jack of Hearts. What will this return? Card 3 less than card 2. This will return false because card 3 is a queen, card 2 is a jack, and they're both of hearts. Okay. If card 4 is another card, okay, card 4 is a 112, okay, which is Queen of Diamonds. And now I can test. So card 1 is Queen of Diamonds, card 4 is Queen of Diamonds. I can do, is card 1 equal to card 4? This will return what? This will return true, okay, because they are equal to each other, okay? However, what about card 1 is card 4? How is card 1 is card 4? How is that different from card 1 equals card 4? Okay. Well, what do you think card 1 is card 4 is going to return? This will return false, okay? So you might wonder, like, what's the difference between equals here and is, okay? So the equals here uses the test for equality, okay? And it will say, oh, you got the Queen of Diamonds. That is it equal in rank to the Queen of Diamonds? It uses that thing, and it says, yeah, Queen of Diamonds and the Queen of Diamonds, those are equal in rank, okay? However, are they the same card? They are not, okay? It's kind of like you draw the Queen of Diamonds out of, I don't know, a red deck, and you have a Queen of Diamonds coming out of a blue deck. Are they the same card? Is this card equal? Is this card this card? They are not. They are two different cards. They are both instances of the Queen of Diamonds. Is this card equal in value to the other card? Yes. But is it the other card? They are not. And we did, when you use is in Python, is a reserved word. You cannot change the meaning of is. Okay. It's going to check to see what is the object and the memory location. The memory location is this address in memory. Okay, card 4 has a different memory location. Okay, and so it recognizes that they are not the same card. Okay, so their values are equal, but they are not the same card. Okay. Over here, I've got the Queen of Hearts. Remember, card 1 is the Queen of Diamonds, is Queen of Hearts equal in value to the Queen of Diamonds. That comes back at false. Okay, so the is checking basically is it the same object, memory location, and the other thing is not. Okay. Let me give you your first view quiz answer, which is the letter A. A as in apple. Okay, so let's build a deck, okay? So we have cards, so now we want to build another object that's going to basically consist of cards, and we're going to build a deck, okay? So the way we will do this is we will create a list. So basically the deck is going to contain a list, okay, called self.cards. So I'm going to start off by creating an empty list, right? So this will be an attribute of the instance, self.cards, and then we're going to fill the cards with, fill this list dot cards with card objects, okay? So inside the init method, I create an empty list, self.cards, and then I'm going to create a loop, all right? And I've got a double nested for loop, which in general is not a great idea, but this does exactly what we need it to do. So we're gonna go, I'm gonna create 13 cards for each suit, for 4 suits. So we're gonna have suit in range 4, so suit will start off at 0 and then go 1, 2, 3, 4, 1, 2, 3. And then rank will start at 1 and go up to 13. And it's going to create a card with that suit and rank. So first it'll do it for suit 0, rank 1, then suit 0, rank 2, suit 0, rank 3, so on and so forth. And once it creates that card, it will append the card to this list of cards. So at the end, it will create 52 cards, and self.cards will contain 52 card objects. When I ask, we're going to have a print, not a print method, we're going to have a method _string, which will print out the deck. And what we will do is we will iterate through the cards here, okay? And we're gonna, I'm gonna create a list of the string representations, okay? So we're gonna get the string representation of the card. We're gonna append it to, right now I have a blank list called results, or the res, or results it starts off with a blank list. So this will be a list of strings. It'll be a list of the string representations of the card. And what it will do is it will return, and I'm not sure if you're familiar with this idiom, okay? /n.join is going to basically do a new line, and it's going to iterate all of the string objects in the list, and it will join all of those things and separate them out with a list. Let me just give you a quick example of this join idiom. So here I'm going to just create a empty results list, and we'll do hello, greetings, goodbye. Okay, and then I can do, so if I take a new line thing here, I can do .join with results here, and this will just kind of, I have to, let me do print on this. But basically, it joins each of these things. And you don't have to do /n. /n is basically a new line. You can do a space, okay? And it will do hello, greetings, goodbye. You can do, you could put in any kind of string here, okay? And it will join them together, right? So you can do, blah, 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 blah. And it will, put that in there in between each of the elements here, okay? So this is a quick idiom, and so you will often see something like this where you'll see, /n type of thing. This is just a quick and common way to kind of create this kind of output. All right, so anyway, this is our deck definition. I've got the init method, I've got the string method. All right, so I'm going to initialize by creating a deck, an instance of the deck class object, capital D deck, instance of it with lowercase deck d, all right? And then let's print this out, okay? And when I print this out, I get the output, ace of clubs, 2 of clubs, 3 of clubs, blah, 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 jack, queen, king of clubs, ace of diamonds, 2 of diamonds, so on and so forth. And it goes all the way down to king of spades, okay? It says output is truncated. If I wanted to see, I can do the full output, and now I have all 52 cards listed out, right? So starting with the ace of clubs, so this is suit 0, rank 1, all the way up to suit 3, rank 13, 52 cards. Okay, great. Let's, so basically the deck has one really important attribute, which is the self.cards list, okay? And so we can start adding methods that interact with self.cards, okay? So I'm going to create a few methods, and because it's a list, I can kind of take advantage of all of these list methods. So I'm going to do a pop card, and so that will do self.cards. We're going to pop. That will basically remove one card from the list, and it will return that, okay? We can add a card, so we can append, this will take in a new object, the card object, and we will append it to itself. I can shuffle, right? And I will have to use the random thing, but random.shuffle takes a list and mixes them up, okay? And these all kind of modify in place, okay? And sort, we'll do self.cards.sort, and this will sort a list in place. Okay, so here I'm just expanding my definition of the deck class by adding a few methods: pop card, add card, shuffle, sort. All right, all of those things, and we're we're adding a lot of functionality to our object definition just by kind of taking advantage of these methods that exist for the list. Okay, so I've got the deck. I can ask deck.cards, which is that list. All right, the length is 52. I can print it out, and again, I get all 52 cards here. Okay, I can shuffle it. I can do deck.shuffle. All right, and I can print it as well. Okay, and so now you can see the deck has been shuffled. I've got 3 of spades, jack of hearts, so on and so forth. So this is now the deck has been shuffled. I can so notice the last card, last few cards. I got 3 of diamonds, 10 of clubs, 2 of spades. Okay, I can go ahead and I can pop the last card. Okay, and so I can do deck.pop card, print it out. It prints out the 2 of spades here. Let me pop the next card. So I'm basically dealing out these cards here. Okay, then it's going to pop the 10 of clubs. And now, what is the length? Now I have 50 cards. And here I just printed like kind of the first, but let me just print the deck again. Print string of the deck, okay? And we can see the 50 cards. And here, the output, the last few cards were 7 of clubs, queen of diamonds, 3 of diamonds, 10 of clubs, 2 of spades. But we dealt off 2 of spades and 10 of clubs. And so now we can see we just have, queen of diamonds, 3 of diamonds. Okay, so we've dealt those off. Okay, so indeed, it's behaving like we'd expect in that we've shuffled the things and we've dealt off these cards, and so now our deck is shorter, and it just contains the cards that we didn't deal with. Okay, I can take the deck and I can sort this. Okay. And I can print this deck again. And what we will see now is, now that after I've dealt off, what were the cards I dealt off? I dealt off the 2 of spades and the 10 of clubs. So we can see the 10 of clubs is missing, 9 of clubs, jack of clubs, okay? And then as far as the 2 of spades go, it is missing. I got ace of spades, and it jumps up to 3 of spades. But the other 50 cards are there. Right? So this is behaving a lot like we would expect a deck to behave, which is great. That's what we want. Okay. I gave you an answer. Let me give you another answer. Second answer is B. B as in bear. B. Okay. Now let's talk about inheritance. Right? So what we want to do is we want to define another class that's kind of like a deck, but it's not. And this will be a hand. Okay? So when you play a game of cards, you are dealt out some cards, right? And so this is a subset of a deck, and we call this your hand, right? So if you're playing poker, you'll get dealt maybe 2 cards or 5 cards or whatever, depending on what game you're playing. If you're playing some other game, you get dealt 13 cards, whatever. That's your hand, okay? And a hand is similar to a deck in that it is a collection of cards, kind of like a list. And we need the ability to kind of remove cards, like pop a card or add a card, much like the deck, okay? But it is different from a deck in that there are things that, operations for hands that don't make sense for decks and vice versa, okay? So for example, if we're talking about poker, you might have a poker hand, and you might want to compare your hand versus another hand and see which hand wins, okay? And you wouldn't do that with a deck. You wouldn't say, here's my deck and here's your deck, whose deck wins. Well, I guess that's a different game, like Pokemon or Magic or something like that. But as far as a regular card game, right, like poker, you're not going to be comparing decks. You're going to be comparing hands. Okay. So this is what we have, and so this is what we're going to use inheritance. Okay. And to define a new class that inherits from another class, you call class, okay? And then you say, I want to define a new class. This is going to be class of hand. But inside you write parentheses, and you put in the other class that you want to inherit from, okay? So I want to say I want to create a new class called hand, and this is going to inherit from the deck, okay? So we are defining a new class, hand, which inherits from deck, and that's how we do that, okay? Versus, when you define the deck, it's not inheriting from anything, so we just do class deck : okay? So defining something that doesn't inherit is just class name : okay? And here we have class the name and something happened. Okay. Parentheses : okay. Weird. All right. So this will do that. And then, okay. So how we want to distinguish is that when we create a hand, we don't want to put in all 52 cards. Okay. Your hand starts off empty, right? You sit down at the table, deal me a hand. Your hand starts off with no cards. And we want to add, okay, there we go. We want to add cards to it. So my initialization method, okay, is we'll have nothing. We'll just create an empty list of cards. We're the hand, we're gonna give it a label. That's just something arbitrarily we decided to do, but we will, we'll give our hand a label here, okay? So that we can kind of refer to the different hands, and we can say, player 1, player 2, player 3's hand, things like that. Okay, so here we're gonna create a new hand, and I can ask what are the cards in the hand. Right now it's just an empty list. Just an empty list. What's the label? This is my new hand. Okay, maybe we'll call it later, player 1 hand, player 2 hand. Okay, so what we can do is we can create a deck, and I can deal off a card from the deck by popping that card. I'm going to do deck.pop card. That's the card. And then we're going to take that card and add it to the hand. Okay, so now I can say print my hand. So when I created a deck, it starts off with a full 52 card deck, and we're gonna, it's in order. So the last card I think is the King of Spades. And so right now, my hand, when I call print, it calls King of Spades. Now, we didn't have to define the print method or the string method or the add card or the pop method for hand because it inherited all of those from the deck, okay? All of those methods, so I can go ahead and use print, I can go ahead and use add a card for the hand because it inherited all of those things from the deck, okay? Okay, what we're gonna do now is we wanna say, all right, can I move cards from the deck into a hand, okay? So I'm going to add a method to the deck class, and we're gonna call this move cards. And so we're gonna move cards from the deck to a hand that's specified, and how many cards do we wanna move, okay? So the move cards, we'll take a hand object, and we're going to start with the self, and then for, we're going to repeat this for the number of times. We're going to just do hand.add card, and then we're going to just basically pop a card from the deck, okay? So it'll do self.pop card. Whatever card gets popped, we're going to add it to the hand by calling hand.add card, okay? And this is where I think object-oriented programming really makes for, in my opinion, elegant solutions, because having, if you were not dealing with objects, okay, and let's say you just had a list to represent your deck and a list to represent your hand, okay, you know, the code is not going to be as simple, okay? You're going to need multiple lines. And here, basically, the moving of a card from the deck to the hand is just one line. It's just hand.add card. And what card are we adding? We're basically popping a card off the deck, okay? And so it looks something like that. Okay, so basically, that just gets added right here. So the definition of my deck class has gotten bigger and bigger, but each of these things, I think, in my opinion, simple enough for us to kind of understand and digest. All right, so let's go ahead and do this. We'll create a new deck. We'll create a new hand. And I want to move 5 cards from the deck into the hand. So we're going to do deck.move cards, hand 5. Okay, what does my hand look like? My hand now looks like it's got the what? The 5 cards. It's almost a royal flush in spades here because basically I didn't shuffle the deck and I just dealt off the top 5 cards. And so there we go. We have that, and I could, at this point, I could also print the deck. And we can see, yeah, okay, the deck only has 47 cards now because basically the 9, 10, Jack, Queen, and King of spades got moved into the hand. Okay, so we've successfully dealt those 5 cards there. All right, here. Now I think this I've done exactly. Yeah, I don't. Okay. Oh, here basically I shuffled the deck. All right, so. If I shuffle the deck and I just print the remains, these are kind of the last 5 cards, I can say, all right, what does my hand consist of? The hand consists of these things, and then once I do that, 8 of clubs, and I ask, okay, just print my deck here, okay? Okay, it has basically everything. And up to the King of Spades, okay. 7 of Hearts, King of Spades, so on and so forth. Okay, so yeah, that's that covers that. Just this idea of relationships between class. You can always kind of ask, what are some of the variables? Now. When you look at this thing, the cards variable itself is it's a list of card objects. So it's a little bit hard to read, but that's what we have. Okay, just keep in mind as you're creating classes and classes are inheriting from other classes, okay, there's a couple different relationships. You have the has relationship and the is relationship, okay? So one object might contain objects from another class, okay? That would be the has relationship. For example, rectangles has a point object, okay? Decks contain or has card objects in them, okay? Or a deck actually has a list object which contains card objects, okay? And one class might inherit from another, and that's when you have inheritance. That's an is relationship. So a hand is actually kind of a modified version of a deck, okay? So the hand is a kind of a deck, all right? And anytime you have these kinds of relationships where one class depends on another, okay, and that it either has to inherit from it or it contains other things, we call these things dependencies, right? And so a lot of the packages that you use have a bunch of kind of interconnected dependencies. Like, for example, pandas in a data frame, if you think about the column in a pandas data frame, it is a NumPy, or that pandas series actually consists of a NumPy array, right? And so a pandas series contains an index and a NumPy array, right? And so that's a dependency. And so if you install pandas and you don't already have NumPy installed, it's going to force you to install NumPy and things like that. And if you have all of your versions messed up, you can run into problems. But anyway, most of those things are handled by your package installation manager. But anyway, you do have these dependencies between packages because, pandas depends upon NumPy because it contains all of these other things. And stuff like that can happen if you create class objects that say inherit from other packages, okay? Like let's say you wanted to create something and you're going to use a NumPy array, all right? Something that's not part of base Python, then that creates a dependency for your thing. And if you want to use your script in the future, it might not work if they make an update to NumPy that changes how some of your stuff functions. Okay, so these are just things to be aware of. Okay, when you override a method, okay, to kind of make it easier for yourself and other users, the new method that you use, okay, should interact and behave in a predictable way that's similar to the old method, okay? It should take the same parameters, return the same type, obey the same kind of expectations, okay? And that way, it will be easier to interact with, right? So, when you do something like I want to add a card, okay, and I don't know, for the hand you want it to do something just a tiny bit differently, you don't want to change it way too much so it's confusing, okay? All right, one thing here though, okay, is one kind of objection is that when we check the variables of the hand, it's a list containing card objects, and this is not human readable, okay? We have the print method, which gives us a string representation, okay? But the card itself, okay, the objects look like this, okay? So there is another method, and it's called _rep, okay? Or representation, _rep bar, okay? This is very similar to the _string method. _string and _rep are very similar, okay? Except the rep, the distinction here is string gets called when you print an object, and it's supposed to be something that's kind of readable and easy. The rep gets called when it just needs to represent the object. Okay, so when it needs to represent the object, it's going to look like this. So this is what happens when you call print, and this is what would get output if you call rep, right? This is not readable by humans, so what you can do is you can replace it with something readable. But you don't want your string and your rep to be exactly the same. Generally for rep, if you wanted to make it readable for humans, what you would do is you would give the command you use to create this object. Okay? So for example, when you create the queen of spades, okay, the command you would use to create the queen of spades would be card spades is 3, comma, queen would be 12, okay? And so that's what rep should do, okay? So, so if I do this here, here I'm gonna create a card. Card 1 is 0, 2, which would be what? The 2 of clubs, okay? When I print card 1, it prints out 2 of clubs, but now the representation of card 1 is not this main card at this memory location, again, not readable to me as a human, but is rather going to give me card 0, 2, which is not as readable as 2 of clubs, but yet more readable than card at this location. Okay, and so that's how we would use the rep, dunder rep bar method there. Okay, we'll wrap things up here. We'll go ahead and end here.